Oh no! Bluey has Hunter syndrome? But what is Hunter syndrome? Well, to answer that question, mucopolysaccharidosis 2, MPS 2, or more commonly known as Hunter syndrome, is a rare genetic disorder characterized as an X-linked recessive condition. It is notably the most prevalent lysosomal storage disease among Filipinos. This disorder arises from a deficiency in the enzyme iduronate 2-sulfatase or IDS, which is crucial for breaking down glycosaminoglycans (GAGs) in the body. Without sufficient IDS activity, these large sugar molecules accumulate in various tissues, leading to a range of health complications. The clinical manifestations of MPS 2 can vary significantly in severity, affecting multiple systems and potentially resulting in progressive deterioration of health.
So, how does Hunter syndrome occur in the body? Well, once upon a time, deep inside our bodies, there was a mighty castle called the IDSG. Within its sturdy walls lived a group of strong and brave knights known as the I2S Warriors. Their mission was noble: to battle the mischievous and complex sugars that roamed the body, ensuring harmony and order. These valiant knights were tirelessly wielding their strength and skill to break down the stubborn sugars. With their efforts, the sugars were transformed into harmless forms that the body could use, bringing balance and joy to the kingdom within. Together, they lived happily ever after, the castle standing strong and the body thriving. But what if tragedy struck the kingdom? What if the ITS castle crumbled or fell into ruin? Without the protection of the castle, fewer knights remained to fight the sugars. The once mischievous sugars grew bold, overpowering the wicked knights. Without their guardians, the sugar began to wreak havoc, damaging the body and its organs. This chaos gave rise to a dreaded affliction known as Hunter syndrome, leaving the kingdom in disarray and in desperate need of a hero.
Alright, let's kick this off with our ears. Did you know that Hunter syndrome can make hearing a little bit tricky? Here's why. Some people can lose their hearing a little or a lot. And this happens because these things called glycosaminoglycans, or let's simply call them GAGs, build up in the ear. And ear infections are pretty common too. When they keep happening, they can make hearing even harder. And all that GAG buildup gets in the way of how the ear does its job. It's like trying to hear someone whisper in a noisy crowd. Now, let's talk about the eyesight. Eyesight can be a bit tricky too, and here's what can happen. Sometimes people can be nearsighted or farsighted, just like how Bandit couldn't spot bingo and hide and seek. There's something called glaucoma. It means that there's extra pressure in the eye and that's not something comfy. And there's a fancy word, pigmentary retinopathy. It means the retina or the part of the eye that helps you see can get damaged. Now for faces, Hunter syndrome can change them a bit. People might have a broad nose, thick lips, or a big tongue. And sometimes their heads grow a little bigger too, and that's called macrocephaly. And then there's how we learn and grow. Hunter syndrome can slow things down. Kids might have delayed learning and intellectual disability, which may worsen over time. Behavioral issues like hyperactivity or features of autism. In severe cases, seizures or epilepsy. All this happen because those GAGs get into the brain, making it hard for it to work like it should. Now, let's talk about breathing and hearts. Big stuff. Breathing might be hard because the airways get blocked, like having a never-ending cold. And sleep might get interrupted because of something called sleep apnea. It's like snoring but way serious. And the heart, the valves can get thick and leaky, which can cause problems. And last, people can stop growing up. Hunter syndrome can make this tricky too. Kids might be shorter or have bones that don't grow the usual way, like stiff joints or a curved spine. Organs like the liver and spleen can get bigger too. And physical milestones like walking or running might take longer because of low energy levels and frequent illness.
Wow! So here we have Bluey's case records. Why don't we take a look at the prevalence of Hunter syndrome? Let's see. Aha! If one Filipino is one sprinkle, then a jar of sprinkle means 10 million Filipinos. Then that means that 3 sprinkles out of 10 jars of sprinkles are only affected. Wow! That's so rare compared to a lot of diseases out there. Wait, let me translate that properly. So, if sprinkles are Filipinos, then 3 Filipinos in 10 million Filipinos are affected by the Hunter syndrome. This is the point prevalence of the disease last December 2019. And as we all know, they are all males assigned at birth. But wait, we also need to remember that females can also be carriers of the Hunter syndrome, which means that they have the ability to pass on these genes to their offspring. But still, I think we shouldn't need to worry since this disease is so rare that we only had recorded 40 cases that satisfied the criteria for the disease since 1999, and 27 people affected by this disease are still alive today.
So, now we know what Hunter syndrome is, what its symptoms are, and how rare it is to get it. But then, how do we know if someone does have Hunter syndrome? Well, the first way to find out if someone has Hunter syndrome is to let them take a urine test. Here, patients pee into a cup, and the doctors then analyze the chemicals that are present in the pee. They're looking for a specific chemical called iduronate-2 sulfatase, or IDS enzyme for short. If IDS enzyme is in the pee, then it's all good. But if IDS enzyme is absent in the urine, it may tell us that a patient may have Hunter syndrome. This urine test, though, isn't absolutely accurate, and it cannot tell us definitively if someone does have Hunter syndrome. To be able to better diagnose if someone does have Hunter syndrome, we instead do genetic testing. Here, we take a blood sample and we analyze the genetics of a patient. Specific genes are responsible for coding for the IDS enzyme, meaning if we look for the gene that's responsible for producing IDS enzyme or the IDS gene and find that it's absent, it can tell us if a patient does have Hunter syndrome. Now, with all that said about Hunter syndrome, it sounds super scary, right? But treatments are available, even if a cure isn't available just yet. One such treatment for Hunter syndrome is called enzyme replacement therapy. It sounds super cool, right? But how exactly does it work? Well, in patients with Hunter syndrome, as mentioned earlier, they have lower levels of a specific chemical called IDS. So, enzyme replacement therapy aims to increase the levels of IDS in a patient's body. It does this by letting the patients take medicine called elaprase, which is like an artificial form of IDS made in a lab. By doing this, the patients who take elaprase have increased levels of IDS, reaching the normal amount of IDS in a person. Another treatment for Hunter syndrome is called stem cell transplant. Similar to enzyme replacement therapy, we aim to increase the levels of IDS in a patient's body. But instead of letting the patient take a medicine that increases the levels of IDS, we instead sort of let them make their own medicine by letting the patient's body make their own IDS. We do this by transplanting healthy cells from someone that doesn't have Hunter syndrome into a patient with Hunter syndrome, thus allowing their body to make their own IDS to reach the normal levels of IDS. Lastly, although there are no known ways to prevent Hunter syndrome because it's genetic, there are ways to be better informed. Genetic counseling can be done for families that may be carriers of the disease but do not display the symptoms of Hunter syndromes to understand the risks and probabilities of their children to develop Hunter syndrome.
And with all that said, we now have a very urgent call to action, specifically for people with rare diseases or even Hunter syndrome in general. Now, individuals with rare diseases such as Hunter syndrome require access to intensive and comprehensive healthcare services. It is crucial for physicians to recognize Hunter syndrome early to prevent the diagnostic delays that can hinder timely treatment. This includes being able to recognize a constellation of symptoms and being able to come to the conclusion that a person has a rare disease or Hunter syndrome. To improve patient outcomes, there is also the pressing need to enhance referral systems, ensuring that patients receive expert clinical evaluations and appropriate biochemical and molecular diagnostics. And I guess most importantly in this context, legislative support is very, very vital. The National Rare Diseases Act or Republic Act number 10747 was enacted last March 2016, which aims to establish a more comprehensive healthcare system for rare disorders. By enforcing and enacting this legislation, we can create a supportive framework that addresses the unique challenges that those with rare diseases face, ultimately improving their quality of care and life.